I love those questions. I don't remember what they were now. Other than the one with x squared, I think there was one more. I don't remember if we solved the other one. That's what I'm saying. Okay, so today is the 17th. So there was a limit. What was it? X squared.
So was it 9? It was limit as x approaches 3, x squared equals 9.
Good. So if you remember last time I said, I'm happy if you just understand and remember how to apply the epsilon delta definition on a linear function. I'm happy with that. It may be simplifiable, something like that, but at the end of the day, it will be a linear function. So I'm happy with that, and that's good enough. However, there was a problem in one of the recommended problems with a quadratic function. And how do we address this? It's a little bit more, I wouldn't say sophisticated, but a little bit more difficult. So I will have to write the same definition. I will have to use the double equivalency. I copy everything else. For every epsilon greater than 0, I will find a delta greater than 0 such that 0 less than x minus 3 less than delta. If I pick x close to 3, how close? Delta close. This will always happen. X squared minus 9 will always be less than. Very good. So it's the same definition. It's just that now the function is a little bit of a problem, because it's quadratic. Okay, I started the same step. Where? Like before. No change there. Where do I start?
Absolute value of x squared.
Of course. Thank you very much. And of course, even if I know nothing about calculus, but I know a little bit of algebra, I have to know something. What will be the next step?
Factor.
Right. There is nothing else. Even if I want to do something else, I can, because it's the absolute value. So then I will factor inside. What do I get?
X plus 3, x minus 3.
Awesome. And now, at this point in time, I will use the absolute value property that says the absolute value of A times B is.
Absolute value of A.
Very good.
I'm on fire.
You are. Thank you. Okay. So now it's not the case, but I'm just going to say I cheat a little bit by simply looking here. And I know exactly which of these two absolute values I need to stay and which one I would love to make it disappear. Because remember, epsilon is a number, and delta depends only on epsilon, not on x. So which of these two I keep, and which of these two I would rather have?
Keep x minus 3.
Yes, I have to keep x minus 3. It's obvious. So I have at this point to estimate. Must estimate x plus 3. I don't have another route. Okay. So now, bless you. So how do I estimate and how do I start? Here's how I start. Would you agree that when we looked, so this is x squared, right? So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what we, oops, I'm sorry, I missed it, sorry. So let's say, I'm going to say that this is 3, 9. It doesn't have to, you know what I mean. I just want to show something. So this is our 3. How far can I have left and right? You can say 5 units, but that's not the point. The point is to show that for as small as epsilon can be, I can choose it as small as I want. I will find a delta. But it's not this delta. It's this delta. So we normally say delta cannot be more than 1. Because if delta is more than 1, then I'm here huge distance, right? So for that reason, we will say that x minus 3 in absolute value is less than 1. And you can say, where did you come up with that? It's because delta cannot be more than 1. Do you remember how many examples we looked at? Epsilon was 0.1. What did we get? 0.1 over 3. Epsilon is 0.2. What did we get for delta? 3 times 0.1 over 4, right? So epsilon was never bigger than 1. Obviously, delta will never be bigger than 1, because we want to show that no matter how small I get epsilon, I will get the corresponding delta. So this is not an assumption that is unreasonable. It's a very reasonable assumption. From here, I have to change this into -1 less than x minus 3 less than 1, which is the way we solve such an absolute value inequality. I don't know how to solve this. I have to change it into this. One more time. This says, find numbers x minus 3 whose distance from 0 is less than 1. Distance from 0 is less than 1. So those numbers have to be between -1 and 1. Then I'm adding 3 to both sides, and I get that 2 is less than x and less than 4. Okay, why am I doing all this? Again, I'm trying to estimate x plus 3, but I can't estimate x plus 3 unless I estimate x. So now please tell me how I estimate x plus 3. What should I do to this inequality? I'm after x plus 3. What should I do to this inequality? What do you think?
Add 3.
Of course, I have to add 3 to all 3 sides. So I have 5 less than x plus 3 less than 7. Of course, I'm close. I'm close to estimating x plus 3 in absolute value. So
But we don't have to worry about the x on that.
I did.
Oh.
I had to start with x. I can't estimate x plus 3 without estimating x. How did I estimate x? Is by making the assumption that delta cannot be more than 1. So once I made the estimate that delta cannot be more than 1, I know that all x values must be between 2 and 4. Right? This is 3. If delta cannot be more than 1, then x must be between 2 and 4. There is no discussion there. Are you in agreement so far? So once I know that x is between 2 and 4, then I know that x plus 3 has to be between 5 and 7. And now I have two options. Option number 1 is the absolute value of x plus 3 less than 5. We'll discuss both options. Or x plus 3 in absolute value is less than 7. Now I have to check which of these two, just to make sure, maybe both, and then it's even easier, right? But I have to check which of these two have this inside, because this one starts at -5 and ends with 5, but it does not include till 7. So this is not an option. What about this? This one includes from -7 to 7.
Yes.
So this one includes everything that I have between 5 and 7. So this I will remove. Not good. And I will say that x plus 3 in absolute value is less than 7. So now from these two, I come back and say that the absolute value of x minus 3 must be, if x plus 3 in absolute value cannot be more than 7, what should I do to both sides of this to get this? So this cannot be more than 7. What should I do to both sides? By, if this cannot be more than, exactly. And this is it. However, now I have to be careful, because you should say, why do you need delta? You already assumed that it's less than 1. Actually, you replaced it by 1. True. But now I have to write a little note, and that's the end of it. Delta must be the minimum value of two values. Which two values? The one that I replaced delta by, and the one that I just got, whichever is smaller. Which numbers? Exactly, and
E over 7, epsilon over 7.
so you can say it's a little bit convoluted, tiny bit, but don't forget what you want to ask. So
Wow.
so once I have x equals 3, right? That was a equals 3. I know that delta cannot be more than 1, which means x is between 2 and 4. And from that assumption, I add 3 to all three sides, and I get two options. X plus 3 to be less than 5, which does not work. Or x plus 3 in absolute value to be less than 7, which includes all this. Then I go back and I say, okay, then if it cannot be more than 7, then I'll say divide both sides by 7. And obviously, it's not going to happen that 1 will be smaller than epsilon over 7, unless you say epsilon is 10. You're not going to use epsilon being 10 to show the proof, right? You will use epsilon 0.1. And then, of course, this one will be smaller of the two. So then in this case, delta will be 0.1 over 7. Yes, I'm sorry.
Can you just write out how, like, the dividing by 10, because I'm...
You mean by 7?
By 7, yeah.
Yeah, so this cannot be more than 7. So if it cannot be more than 7, you divide both sides by 7. 7 over 7 is 1. Epsilon over 7 is epsilon over 7.
Still.
She got the 7 from the right side with the inequality.
I get that, I think.
Then just
Well, I definitely
substitute.
have the
Since there's two
Absolute.
absolute values, when we have to figure out what x plus 3 can be within, and it has to be under 7.
I understand, then why are we dividing by 7?
Because I have to have the absolute value of x minus 3 on the left-hand side.
I don't understand how you're pulling the 7 from the bottom.
So the absolute value of x plus 3 is less than 7. So I divide both sides by 7. So the maximum that it can be is 7. So if this is the maximum possible, which is 7, I simplify 7 by 7. And I get on the left-hand side x minus 3 in absolute value. And I have epsilon over 7 on the other side.
It's still x plus 3.
Yeah, yeah.
X minus 3.
Is that better?
Yeah, I understand it now.
Good. Yes, please.
Just don't put anything like that on the test.
We already talked about that. This is a quadratic function. If you remember, I said that last time.
So when the homework problem asks you to verify that that another set would be between 2 and epsilon over 8, you would substitute in the 2 where you.
Hold on. Say it again, please. I'm sorry.
Sorry, the homework question where it says to verify that.
This
it's
one?
between, yep. That it's between.
So it's a different
another
homework
set.
now. It's a different problem. Are we
No,
still?
It's the same.
Okay.
It's the same function.
Okay.
But it asks you to verify that that epsilon, sorry, that delta rests between the minimum of 2 and epsilon over 8. You would substitute 2 in where you did, it'd be negative 2 less than x minus 3 less than 2.
Can I see the problem, or is it in the book, or?
Yeah, it's over 33. 116 or.
Okay, now you make me open this heavy book. Okay, which
You,
page is it? Which page is it now? It's fine. Which page is it?
117.
Yeah, 7.
107? Are we going backwards?
What number was it?
It's not 33.
Oh, and, okay, 107, yes, number?
Sorry, no, it's not.
118.
118, sorry.
Okay, that's what I thought. Okay, and 118, number?
33.
33. Verify that another possible choice of delta for showing that in example 4 is delta minimum 2. Yeah, because in this case, they chose, instead of delta being 1, they chose 2, which will be the same thing. So then you will have 2 here.
Right, that's what I was
Then
asking.
you'll have 2 and negative 2 here.
Yep.
And you'll still have to add 3. So then this would be 1, and this would be 2 plus 3, 5, right? Right, so this is, so 2, negative 2, and we add 3, right? So negative 2 plus 3, this would be 1, and this would be 5, 1 and 5. So then you would have to use the absolute value with 5 in here. So let me do this because it's interesting what they're asking. I just don't know.
Well, if you find it interesting, we find it difficult.
Well, but if you had followed this with me, I think it's just pretty. But no, I'm not going to ask you to find the limit from a quadratic function. So they were saying that delta equals the minimum of 2 and epsilon over 8. Okay, so we had the absolute value of x minus 3 less than 2. So then negative 2 less than x minus 3 less than 2. I'm adding 3, 1 less than x less than 5. So I'm adding 3 now. Okay. So 3 less than x plus 3 less than 8. That's how you get it. From here you have x plus 3 less than 8.
Oh yeah, let the left side be 4. Instead of 3.
Oh, it's 4. Okay. Thank you. So of course you cannot use the absolute value of x plus 3 being less than 4. You have to use 8. So that's how you get that. Yeah. But it's clear because once they say I said 1 and then they said 2. But there is no such thing. I mean, if you use 2, it doesn't mean that the function that has that limit. You are interested in the other way around, to make epsilon as small as possible and still be able to determine a corresponding delta. Good, very good question. Anything else? Is there? I think there was one more question, but I don't remember exactly what it was. Or maybe we solved it before we started. Is there anything else? Okay, so we are trying to finish all problems for the packet, and I would like to, do we need to look at another f prime? Yes, very good. Do you have a preference for the type of function for this f prime? A rational, quadratic, you can choose. You can choose from 21 to 31, any function here that you can think of. Obviously, some of them will take us 10 minutes, some of them will take us 5, some of them may take us 20 minutes.
What page is that?
It's page 163. It's a section 2.8. So, any preference? Okay, so did we do the square root of x? No, I want to start with that because this is very important. So we want to find f prime of x. And let me choose another. Yeah, we did 29 last time. I remember it was the last problem we did. So let's look at f of x equals 1 over x. So we want to find f prime of x. So far we have not learned differentiation rules. We will learn them in chapter 3. But for now, we only have the definition. So let's start with the square root of x. So we are asked to find the derivative for f of x equals the square root of x, f prime of x, using the definition. And moving forward, we cannot forget this definition. This is not the epsilon delta definition. We are talking about the f prime. So this is something that we have to remember moving forward, that the derivative of a function is determined how? Using the definition. There are other methods, which we will appreciate in chapter 3. But for now, f prime of x equals
Limit x approaches.
yes, but the definition is with h. Yes? Yeah, so let's write the definition, f of x plus h minus f of x divided by h. This is extremely important. We cannot forget this one. And now, because this is what we've been doing from the beginning of the semester. We did this first, then we analyzed this, and now we're putting them together. Very good. So then limit as h approaches 0. And now you can dictate, please.
Square root of x plus h.
Very good.
Minus square root of x.
Very good.
Over h.
Good. When I'm asked to find the limit, what is the first thought that comes to mind? Although I may not write it or I may not say it to people, but I still have to do it. Plug it in. So what do I get? 0 over 0. So there is hope. Good. Now what is the next step? It depends on the function. And since the function is what it is, then I will have to. Very good. So I will multiply by
X over square root of x plus h plus x over square root of x.
very good. Awesome. And now what happens next? Remember, I had a lot of times we had a lot of times in this semester in which I said, please commit this to memory. The tangent graph, the arctangent graph, the natural log graph, the a to the x graph, right? So I'm going to say this now. We have to commit this to memory. This has to follow us everywhere we go is the definition of the derivative. And the result for this function we have to remember moving forward. So what do I have at the top?
X plus h minus x.
And the bottom, I just have to copy it. What happens at the top? And what happens with any difference quotient? Two things. Please refresh our memory. What happens with every time we determine the difference quotient?
All not h must go.
Yes. In some of the others, but that's a bonus. That's a plus, right? I don't know. But all terms with no h must go away. What else has to happen for sure?
H on the bottom.
H at the bottom has to go away somehow. Yes, I cannot erase it, but it has to go away. Good. So then these two go away. I recommend let's write this one more time. In order for everyone to see, and because I don't want to simplify in a sum. And now I will simplify only at this stage. Please understand, if you drop the limit operator before the last step when you put the number in, I will have to deduct a little bit of point, and I don't want to do that. Without the limit operator, it makes no sense. So this does not equal this. The left-hand side that you see there does not equal this. It equals the limit of this. So please make the distinction and understand that you cannot. Okay, so now finally, the numerator goes to 1 and the denominator goes to?
Square root of x plus h minus x.
So if you get rid of the limit, you times the operator.
So it means when I can get rid of this only when I make h approaches 0. I cannot just simply disregard it. So when h approaches 0, then I drop the limit operator. So what is the answer? Say it again. But I have the square root of x plus the square root of x. Very good. We have to commit this to memory. Moving forward, when I say how much is the square root of x prime, what will you say?
1 over 2 square root of x.
That's it.
I just wanted to make sure that's the
Yes.
prime. Okay.
Yes. So we're done with this. Moving forward, we will always remember this. Okay. Now the other one, which is 1 over x, very important. So f of x equals 1 over x. Please find f prime of x for me. And please give me the final form. Okay, do we have the answer? Yes? the difference quotient first. Because if we don't copy the difference, that's not the difference quotient. We have to copy the difference quotient first. So f prime equals limit as h approaches 0 and write the difference quotient. And then slowly, carefully plug it in. With negative. With negative in front. Are we there yet? Can anyone dictate other than Joey? Yeah, okay. Can anyone dictate? That was good. Very good.
Yeah, you have to get that.
Well,
down.
yeah,
Same
the
thing
same
on
amount
here.
of x plus h. And on top is so
We've done this many times
X minus
with
X.
more complicated functions than this one. Would you agree?
yeah.
More, way more complicated. So now,
X minus X plus H plus
good. So now the top. Yes? Or in parentheses, or you distribute. That's fine. I accept both. Obviously, these two go away as expected. So limit as h approaches 0 from negative h over x plus h multiplied by. Very good. Now that second step is done. And now I can use the limit operator. Negative 1 over. Do you all agree with that? We will commit this to memory. Sorry, there are a few situations in which we have to remember this. So the derivative of 1 over x is negative 1 over x squared. Please, you want to say something? Yes.
Do you want us to write out that step where we multiplied it by 1 over h? Or can we just move it there?
By moving it there, you mean where?
If-
Because this is in the
If
denominator.
there was a step in the middle where we rewrote it as 1 over h times x times x.
Oh, you want to write an intermediate step. Oh, yeah, that's fine. Let's limit as h approaches 0 from
Yeah.
negative 1 over x times x plus h. Yes, I agree.
Yeah, instead of I just mean without
Yes.
writing the times, as long as
Oh,
we do
yeah.
something.
It's 1 here. Yes.
Okay.
X plus h. I'm going to delete that and erase it. So it's negative 1 over x squared. Yes, that's fine. Yes, please.
So for questions like this on the test,
Yes,
do you want us to write out this whole thing, or
yes.
can we just use the exponent rule?
Oh, we have not discussed that.
So you want us to write
You,
out this
you don't
whole
know the quotient rule yet. You don't know how to differentiate the power yet. You don't know how to differentiate ratio yet. You cannot use the differentiation rules just yet. Not on this test. On the second test and moving forward, yes. But right now, we don't know any differentiation rules. Okay, can you take his cell phone from his, okay, just take his cell phone. Take it. Okay, good. Any questions for me? Yes, please.
So at the very end, you have
Yes.
so you want to remultiply the denominator.
Yes, the denominator is h over 1, so I have to flip because that's how we divide two fractions.
So at the very end, when
Oh, yeah.
x squared plus xh,
so after you multiply that cost, down to the f. So how do you get rid of that h?
As h approaches 0, where does h go?
It's 0, so you just get, okay, that, yeah.
So that's how I apply the limit operator, right? The limit operator says when h approaches 0, what do you get? And that's how you, okay, very good. So let's go back and finish up the checklist. So 42 on the checklist is done because we looked at examples last time. 43 and 44 are both done. Okay, so a function f is differentiable if its derivative exists. In other words, if the function is continuous, it doesn't have vertical tangent cost per corner. It is differentiable in an open interval if it is differentiable at any x value. So just remember this idea, like with continuity. And can I say that if a function is differentiable, is definitely continuous? So one more time. Can I say that if a function is differentiable, it must be continuous?
Yes.
Of course. If a function is not continuous, it will not be differentiable. But can I say that if a function is continuous, is it automatically differentiable? No, because you can have cos corner or vertical tangent. But if I say the function is differentiable everywhere, you know for sure that it's continuous everywhere. Is that clear?
Yes.
But if we say continuous, we say the converse is false. If I say if the function is continuous, do you assume it's differentiable everywhere? No. You have to look at it. Okay, so that was the last page of the checklist.
Do we do the other indeterminate cases?
No, we don't know. We will not encounter them till later. We encounter 0 over 0, infinity over infinity, and we encounter the difference.
Right.
The powers and the products will come in later.
Okay.
Yes.
So is that
I just wanted you to see them from the very beginning.
okay.
So this is a complete list. There are 7. We only encountered so far. I have them again on checklist for chapter 3. 0 over 0, infinity over infinity, and difference. This is all we know so far. Okay. So this should not be any problem for you. So you can do that. So now I'm coming back. There is no problem here. This is what we just discussed last time and today. So the only thing that I still have to discuss is 2.7. So 2.7, derivatives and rate of changes. Derivatives and rate of change. Oops. Here is a question for you. What is the difference between f prime of x versus f prime of a?
One's a function, one's a value.
That's it. That's the answer. So this is a function that gives the slope of the tangent line at any point where the function is what? No, we need more stronger differentiable. And this one is the value of f prime of x at x equals. That's it. So this is one particular value, one number, not a function. And this is a function, f prime of x. Okay. One more time, can anyone give us the definition of the f prime of x? One more time, because I want to see all of them here.
Limit of h is approaches
When h approaches 0, very good.
the function for f of x plus h minus f of x over h.
Good. For f prime of a, we do have 2 definitions. So how many definitions we have for f prime of x? 1. We have 2 definitions for f prime of a. You know me, I write big, so I don't have enough room here. So I'm going to go to the next page. So the first definition for f prime of a is limit as x approaches a from f of x minus f of a divided by x minus a. It's still the same thing. And the second one is f prime of a equals limit as h approaches 0 from f of a plus h minus f of a over x minus a. Same thing, just a different way of writing it.
Shouldn't the second one be over H?
Oh, yes, of course. I looked there and I started talking instead of paying attention. Thank you. My apologies, of course. So now the question is, and I'm sure it's on your mind, if you're asking me to find f prime of a, which of these two definitions will I use?
First one.
It doesn't matter. However, it depends on the function. So I don't have a recipe for you, but some functions simplify very well with this, and others not. And they simplify much better and easier with this definition. Okay? So it depends on the function. So now this is the last thing before we conclude chapter 2, and I would like you to choose anything you want, and these problems are on page 151. So 27 through 32. Yes, please.
So with the two definitions, right?
Yes.
Is it simply just trial and error to figure out which one was simplified best?
No, not really. Not really.
Could you also say that you would take like the first approach if the function was linear, kind of easy, where you could plug in?
It depends. It's a very good question. So your colleague has this exact same question. Okay, bless you.
Let's see.
If I can factor, this is a better option and easier option. If I cannot factor and I need to rationalize, this may be a better option. It depends on the function. So that's why let's practice with a couple of them and we'll see the difference. I can't just tell you, give you a certain recipe and say, use only this or use only that. I can't do that. It depends on the function. Okay? So let's choose any problem you want from page 151.
32.
Are we not doing chapter,
27 through 32. I'm sorry?
2.8?
This is what we just completed.
Oh,
And we went back to 2.7. We started with the function first. I wanted you to see the derivative first, and then I wanted to go back to a special case of f prime of a. So 2.8 was the definition of the derivative as a function. And is that clear now?
Yes.
Okay, and f prime of a is, there's a special case when x is a. Yes, Joey, you want to say something?
Maybe we'll figure it out, but if f prime of a is the value of f prime of x equals a, wouldn't x and a be the same value?
Yes, you can say, I don't want to use f prime of a ever. I'm going to determine f prime of x and then just plug in the value in there. There's a third option. But sometimes with a number it's easier than just having, depending on the function.
Okay.
But yes, normally when a problem is asking you to find f prime of a, unless they specifically, and this is not going to be the case, use the definition of f prime of a. No. Just you're asked to find f prime of a. It's up to you. You can find f prime of x first and then just plug it in. Replace x by 5 if a is 5, and you're done. Or you use one of the two. It doesn't matter. You're not gonna. No one is going to indicate what type of which definition to use. If 32 is on the checklist, I cannot do it.
Like for our homework.
So let's look at
30?
which one?
30 is on the checklist.
Oh, okay. I was just saying. I didn't look. I was just saying if it's on the checklist, I still want you to work on something. So 30 is on the checklist. Okay, you want to do 32. Very good. 32 is a good one. So 32 and 151, we have f of x, which is 4 divided by the square root of 1 minus x. Perfect. So the question is asking us to find f prime of a. Now, would you like to use any of these two definitions? I recommend that let's see at least one. Now, because it's the square root, I think it's easier to use this one. I haven't checked for every function to give you a recipe. I haven't checked for every function and say, for these functions, this is easier. For that type of function, it's more difficult. And the difference is not that big. So it doesn't matter. So you want to use the first or the second one? With the square root, I think it's easier with the h in there, but because I won't be able to factor, right? So, okay, so limit as h approaches 0 from, let's write the definition first, a plus h minus f of a divided by h. And now let's dictate, please. H approaches 0 from
4 over square root of 1 minus parentheses plus
yes, or you can distribute, that's fine too, minus 4 divided by the square root of 1 minus a, everything divided by h. And yes, like before, I always say, don't forget, plug it in, plug it in, plug it in, but you know exactly what you're going to get. What are you going to get when h approaches 0? Over 0 over 0, of course. Good. So then what do I have to do? I'm going to pull out a 4. I refuse to keep a 4 in there and drag it on. So the least common denominator at the top is
square root of 1 minus a minus h times the square root of 1 minus a.
very good. The adjustment for the first one? Very good, thank you. The adjustment for the second one? Good. Remember, I took the 4 out. So what I have at the top is the square root of 1 minus a minus the square root of 1 minus a minus h. Limit as h approaches 0. I flip the denominator and I get 4 in front still. H, the square root of 1 minus a, the square root of 1 minus a minus h, and I have to copy the top. We just had a similar example a few minutes ago. You cannot say no because I have proof. I can turn the pages back. And I know what to do. And careful, let's take a look. This is not a problem. When h approaches 0, who cares? This is the square root of 1 minus a. This is not a problem. Who cares, right? When h approaches 0, this is the square root of 1 minus a. This is the problem, but I can't do anything to it. So what am I rationalizing? Of course, the top. So don't even think of rationalizing something from the bottom because they're not 0 anyway. So I have the square root of 1 minus a plus the square root of 1 minus a minus h over the square root of 1 minus a plus the square root of 1 minus a minus h. What happens next? Yes, I go to the next page, I know. But then
wouldn't the top be 1 minus a plus 1?
Line.
a minus b times a plus b is a squared minus, very good, minus.
A, or parentheses,
Okay, let's use parentheses, that's good.
a, yeah, 1 minus a minus h.
Very good, perfect. So this is h, the square root of 1 minus a, the square root of 1 minus a minus h, and the square root of 1 minus a plus the square root of 1 minus a minus h. Yep. Yep. Good. That's okay. It's really nothing. Those are friendly. This is friendly. This is friendly. This is friendly. No problem there. Okay, so 1 minus a, the 2 will go away. The negative a plus the a will go away. And the negative h, negative h will be h. So the numerator is h, and I'll simplify. I normally don't like to do that, but since I have so much to write. Okay, so now let's write it just the last step. H approaches 0. 4 over the square root of 1 minus a, the square root of 1 minus a minus h, the square root, oops, I didn't mean that, plus the square root of 1 minus a minus h. And I have to delete something here. Good. Not a problem. The problem is gone.
So the last H was crossed out along
With this one.
What about that other H?
yeah, the last, no, because H is 0.
Yeah, this is the H. It's this one. Minus minus H is H. 1 with negative 1, negative A with positive A, negative negative H is this one. I was lazy. I didn't want to write them one more time.
Okay.
So this is this one.
All right.
The opposite of negative H is H. Is that okay?
Yeah.
Good. So now everything is safe. H is in the domain, 0 is in the domain of this function. The top is 4. The bottom, when H approaches 0, when you multiply these two, what do you get? Awesome. Very good. And now, when H approaches 0, what do you get here? Very good. Awesome. Put a 2 in front and the square root of 1 minus A. As I said, some of them with using the definition are more difficult than others. Now, I also would like to show you the at the end of the checklist, before we look at one more problem, the different notations for the derivative. So many different notations. Different books have different notations. F prime is the same with y prime, is the same with the derivative of y over the derivative of x. The derivative of f with respect to x, I should say. The derivative of f with respect to x. The derivative of f. The derivative with respect to x of f of x. So all these are just notations. They all mean the same thing. This is what is called Leibniz notation. Okay? We are going to use this, this, and this in this class. Okay? The rest are fine, but we're not going to really use those. Okay, and I'd like to look at one more problem, and then I'll tell you what we continue with. Yeah, I looked at just this right now, just draw my attention. 19 on page 151. And I think it's selected by my department as well. If an equation of the tangent line to the curve y equals x at the point where a is 2 is y equals 4x minus 5, find f of 2 and find f prime of 2. Okay, yes, please. Yes. Yes, of course. Thank you very much. I'm losing it, am I? Sorry. Of course. I was thinking of the next step. Thank you. My apologies. Thank you, Paul. Always say something if you say something, please. You may be right and I may be wrong. I hope it doesn't. I hope it doesn't happen too often, but please keep an eye on everything. Okay, so we are told that there is a function. I'm just graphing an idea, not something that I see here. So here's a function, and this is x equals 2. And at x equals 2, this line is the tangent to the graph at x equals 2. And this is, the equation of this line is 4x minus 5, y equals 4x minus 5. They're asking us to determine two different things. They're asking us to find f of 2, and they're asking us to find f prime of 2. So let's analyze first the f prime of 2. What does f prime of 2 say? Okay, let's go back. Say it again.
The value of f prime of x is 2.
Correct. What does that mean? Perfect. Perfect. It means the slope of the tangent line to the graph of f at that point is
2.
no.
X is 4. It's 4x minus 5.
The slope has nothing to do with the equation of the line. So So you're right. So this is the rate of change of f prime of the function f in 2, which means the slope of the tangent line to the graph of f at this point. What is the slope of the tangent line? So let's look. We are given the equation of. We are given the equation. We are given the equation of a line. Can anyone from algebra tell us what is the slope of this line?
4.
Correct. One more time. What is the slope? Good. So then f prime of 2 must be?
4.
That's it. Very good. Perfect. Now, so we established this. Is it clear? Everyone? Yes? Okay. Now we want to determine f of 2. How? Say it again. Is this okay? Is this clear? Is it? Can I move on to f of 2?
Why is that prime?
Oh, okay, because
So we know that f prime gives the slope of the tangent line to the graph at any point. It must give this a slope of the tangent line at this point, right? As well. But since I have the equation of the line, and I know that this is the slope mx plus b, when I compare the slope with mx plus b, or I should say mx to 4x, then I know that the slope of this line is 4. So because this line is tangent at this point, this must be also f prime of 2, because f prime of 2, it gives the slope of the tangent line to the graph at point x equals 2, comma, f of 2. Is that okay? Is it clear, Nico, or not? So f prime of 2 is the slope of the tangent line at 2. But I have the equation of the tangent. So I have the equation of the tangent, and the slope is 4. That it must be the case that f prime of 2 is 4. Because the rate of change of the tangent at that point is 4. The rate of change of the function at that point must be 4 as well. Yes?
Why is that the equation of the tangent if it's the equation of the function?
We're not given the function. We're only given the tangent at 2.
Oh, I didn't know that.
Yes. Yes, this is the tangent. That's why I graphed it here. So y equals 4x minus 5 is the tangent, the equation of the tangent at 2. So now we want to find f of 2. How much is f of 2? Well, this is a point, right? So I have to find f of 2 here, if this is the coordinate system. So I need to find here f of 2. So how much is f of 2? Yes, 4 times, because this point is common to the tangent and to the graph of the function. So f of 2, because it's the tangent, the same point. I read from the same point. If I read from f of x, or if I read from the tangent, this has to be the same value of y. So 4 times 2 is 8. 8 minus 5 is 3. Because we read from the same point. And the point is a common point of the graph of the function as well as the tangent. So if I plug in, and you will see what happens later in chapter 4. Okay? We will be using this tangent to linearize the function near that point. So if I read from the tangent, or if I read from the function, I have to get the same y value. Is that clear? Everyone? Okay. So for the rest of the day today, we have a test now. No. So I did copy for you a previous test. So we're going to start working on this. Thank you. Okay, then I will give an assessment. I'm going to watch you work on these problems, and I will have an assessment with a grade at the end of the day today.
So you weren't joking.
I wasn't joking in the sense that we have a test today. So it's open notes. This is open notes, open book. You can